So this is my it's kind of cheesy diagram. It's not very colorful, right? But this is kind of my interpretation of really what we see building off of Dr. Navio's work. And I think he just came out with another paper recently. Did anybody read that one? So he's got his cell danger response. It goes through phases. But this is what I really think we see in our patients is we have physical, chemical, emotional, microbial stress. That triggers our cell stress. That activates our cell danger response. And that cell danger response, that's that sick, our patients, you don't feel good, right? Anybody have a virus before? You feel crappy for 5 days? That's the cell danger response. You're hypothyroid at that point, cellular hypothyroid at that point. You have chronic inflammation, you're depressed. Why are you depressed? Because your body's trying to get rid of serotonin. And so if we can deal with that stress, the threat is addressed, and then we restore health. We're always kind of going through this cycle. This is kind of a normal ebb and flow that we should all kind of go through. The problem with some of us and many of our patients is the cell danger response never really shuts off, right? And so if that cell danger response becomes persistent, then that shifts us from this homeostatic regulating system to an allostatic regulating system, right? So we have to adapt to this stress load. And so we get a couple things that happen. We get allostasis, and that allostasis, that shift in regulating, changes how our GI function works. So is our GI function just dysfunctional, or has the GI physiology actually changed to adapt to the physical stress? If you've got chronic stress going on, do you need to put more food in the system? Or more in fight or flight, right? Not rest, digest. Thyroid physiology changes. And I look at thyroid physiology, I call it a spectrum disorder. Because initially it starts as a cellular event. You deactivate thyroid hormone locally to slow metabolism down. And if you don't get rid of that stress response, the next piece of that that's going to occur is that cell danger response results in the release of something called DAMPs and PAMPs. You guys heard that term? If you haven't read the paper, you'll understand what it is. But these are really signal molecules. They're DNA-associated proteins and pathogen-associated proteins to trigger to the immune system to say, hey, we got damage here. These are the guys you want to come clean up. And the good or bad news is that the thyroid gland is very sensitive and reactive to DAMPs and PAMPs. And when they start to pick up on those DAMPs and PAMPs, it triggers autoimmunity at the thyroid gland, something we call Hashimoto's. Is it a mistake? I don't think so. If you think about it, if I had a hose, right, and I want to change the nozzle, but I needed to, I don't want to walk over and pinch the hose for me, right? So I pinch the hose, I'm going to put a valve on, you'll pinch it, you'll hold it for me for a couple minutes, and then I'd let it go, right? But if I said to you, look, hold that hose like that, I'm going to take this end off. You know what, the one I got, I really don't like. I got to go to Home Depot. I may have to go to Lowe's, maybe Ace. Ace has got everything. Ace is the place, right? And so you're not going to stand there for an hour or two while I shop, right? What are you going to do? You're going to go turn it off at the spigot, right? Turn the water off. So what does the innate intelligence of the body do? In a chronic stress situation, is it shut off the gland? We don't need all that thyroid hormone, right? And so what happens then, we start to see autoimmune attack on the thyroid gland, and everybody's trying to fix the antibodies. I got to lower the antibodies. I got to fix the thyroid issue. You'll never fix a thyroid issue until you deal with those cellular stressors are. Does that make sense? Then we've got cardiovascular systems change, adrenal physiology changes, our energy mechanisms, immune, hormone, neurotransmitters, all this stuff starts to adapt to the chronic stress that's going on at the cell. And that drives our patients to have what? Symptoms. And what do we do in allopathic medicine? It's all about, hey, let's manage these babies. Let's just physiologic whack-a-mole, right? Let's just knock them down. But we have to be careful in our business too that we're not trying to do the same thing, right? Can you give me a supplement that makes me do this? Can you do a supplement that makes me do that? I mean, you've all seen the patient that comes in and they want to know what you can add to their 20-pill regime. And I'm not talking about 20 pills, I'm talking about 20 bottles of stuff, right? And the first thing you have to do is what? Get them off of the stuff, right? That's number one for most of them. And the medical management many times actually triggers what? More stress on the system, right? So you get somebody who's got high blood pressure because their vessels are adapting and now they've got high blood pressure, the medical management may be to go take a ACE inhibitor, which is going to now, or angiotensin II inhibitor or something like that, and now you're actually going to get something that medication, that treatment, that angiotensin II inhibitor actually changes thyroid physiology. It actually drops their TSH, so guess what you won't see? You're not going to see that they have a thyroid issue. Their doctor's going to say, you're just, what? Nuts, crazy, lazy, eat too much, you don't exercise enough, because we can't see it, because the medical management contributes to the stress. And so this is the cycle we see our patients in. Eventually we see allostatic overload, and that shows up as pathology and disease, and then what do? We go in and we cut it out or medicate it out, and again, that contributes. That's the cycle of our patients. That's how the average 60 or 70-year-old winds up on, what, 6 to 7 prescription medications and 2 to 3 over-the-counters. And that's just the healthy sick people, right? You know, I'm sure most of you, if you've been doing this any length of time, you have patients that are coming in there, they're taking what? 5, 10, 15, 20 medications, and their doctors just don't get it. And my big issue from a thyroid perspective is, I think hypothyroidism is protective, and when you jam a bunch of thyroid hormone into somebody's system who's trying to shut it down, that is a recipe for disaster. Why? Because that T4 that's not supposed to be very active binds to what they call the integrin receptors on the outside of the cell. It can help trigger cell multiplication, non-genomic effects. Okay? Upregulates stem cell activation. That is what? When you activate or cause a bunch of sick cells to multiply, what do you get? Yeah. So I call this process, because every one of your patients wants to know what's wrong with me, right? So I just call it this, multi-system adaptive disorder. I don't think it's a disease, right? I used to think it called it dysregulation, but it's not really, in most cases, it's not dysregulation. It's an adaptive disorder, right? And patients want to know, how do I get rid of all this stuff? The way you get rid of it is you got to do this, right? So, how to manage the chronic inflammation, oxidative stress. So we're back to this, because that whole process is driving, when you have all that stuff going on, what are you driving? Chronic inflammation, oxidative stress. Are those things the problem? Kind of, but it's kind of the body's protective mechanism. So how do we kind of manage this process? We have two choices. That's direct anti-inflammatory, antioxidant response, or we could support the natural cell defense. And you can do both, but you got to be cautious and careful with both of these. So the problem with loading direct antioxidants and anti-inflammatories is that you're doing like a one-off, right? You're loading one process and not supporting the whole process. So like if you take SOD, you can catalyze superoxide, but now you've got a whole bunch of H2O2 that you got to deal with. Now do you have the ability to deal with that? Is that pathway open? You only pushed one pathway. If you take NAC, right, we want to take NAC, we'll support glutathione support, right? But if you take NAC, it actually inhibits something called NRF2. Have you guys heard of NRF2? That's the master regulator of antioxidation and detoxification in the body. So you're actually, by taking NAC, you may actually be inhibiting the body's natural, innate way to detoxify, because NRF2 turns on about 200 different genes that deal with antioxidation and detoxification. You want to shut that down? Probably not. Can we provide glutathione? Absolutely you can provide glutathione, but if you take too much glutathione, it becomes what? It becomes a free radical in itself, right? And then you have to be able to recycle that. So then you need some vitamin C, but if you do high dose vitamin C to try and recycle it, then you can have to run the risk of causing some DNA damage, right? And then if you can take a whole bunch of anti-inflammatories, and everything has a consequence and an unintended consequence. So I'm not a big try and push things heavy and hard. I think we just got to coax the body to help it out sometimes. So direct antioxidant and anti-inflammatory strategy, one of those things you can do, it can support, when you do those NSAIDs, you can actually support bacterial overgrowth. So now you have a patient who's taking lots of anti-inflammatories on a regular basis, and they go, I got chronic SIBO, I got chronic gut infection, I can't get rid of them. Maybe it's that anti-inflammatory antioxidant support they're taking every day. Should they be doing that? Maybe not. How about can be oxidant or pro-oxidant? We just talked about that. You can give something, but if you give something that's a antioxidant and then it gets used, it now becomes the pro-oxidant. It's the thing that has to then be recycled. Things have a hormetic effect. You've got to make sure you're not pushing harder than the body can manage it. It can hinder the natural anti-inflammatory, antioxidant pathways. We talked about that with NAC. The problem with a lot of the things that we take, they have low absorption and bioavailability. We'll talk about that in a second. And a lot of the things that we do can inhibit phase 2 and 2.5. Okay? Woo woo, right? So phase 2 detoxification, right? Everybody knows it's phase 2. 2.5 is what Dr. Kelly coined, because you can do phase 1, right? Phase 2, but then you've got to get that stuff out of the liver, out of the hepatocytes and into the bile. That's 2.5. And some of the things that we do from an anti-inflammatory standpoint, if they're inhibiting NRF2, they are inhibiting the clearance of those things out of the liver. So we have to be cautious. So chronic inhibition of ROS and inflammation reduces the innate cell protection, increases the risk of infection, reduces the appropriate repair and regeneration, reduces detoxification 2 and 2.5. That must be really important. That's why I put it in there twice, Kelly. And it reduces stem cell activation and function. Your stem cells, your repair regenerative mechanism in the body, right? Do you want to inhibit that? Not too much. So we got to find our sweet spot to create a little bit of stress in the body. We don't want to overload it. What are some really good ways to low level increase oxidative stress? Again, it's not the sexy things, but it's the things you really want your patients to do that they don't want to do, right? Mild to moderate exercise is awesome for increasing mild amounts of reactive oxygen species. When you increase it, that exercise activates reactive oxygen species, increases NRF2. And when you increase NRF2, not only do you release a whole bunch of antioxidants and stimulate those genes that create those things, but you also then increase phase 2 detoxification. So that's important. So exercise helps you detox, right? Other thing that can help is calorie restriction, right? And most of us are trying to help our patients out. They don't need 5 small meals per day, right? They don't even need 3 meals per day, most of these people. Think about this. If they have cellular stress and their thyroid hormone is being deactivated locally, right? Do they need more food load at that point in time? They can't get it into the cell. Think about that. If they're in cell danger response, thyroid hormone is deactivated, they're going to have decreased glut transportation of glucose into the cell. They're insulin resistant. But their brain is still craving food, or their habit is to eat, but they don't have the metabolism to burn it. Okay? And so what did we tell them to do? Keep feeding the beast, right? Keep putting all that glucose into the system, 3 to 5 meals per day. You don't want your blood sugar to drop. And what did we really do? We created more illness and disease. We drive glucose that can't get into the cells down poor pathways that help feed sick cells. So here's a great slide. Here's our phytonutrients, foods that can activate NRF2. This is our sulforaphane. Exercise increases the reactive oxygen species. I'm going to go through this in a sec, but when you have that reactive oxygen species, it separates what we call keep 1 from NRF2. NRF2 then enters into the nucleus, and that stimulates our antioxidants and our phase 2 detoxification processes. But if you take antioxidant supplements on a regular basis, you're inhibiting the ability to make that reactive oxygen species. You're calming that down. One of the worst things you can do, and I know people who do that, is they take those things right before they work out. Is that good? No. Because then they can't support the healing process, and then they also can't detox their body.
Can you talk a bit about
What do we do, right? So what do we
NRF2?
do? How do we fix this stuff? Well, this is the thing we want to push, right? So this NRF2 antioxidant response element pathway, right? This is the master regulator of the antioxidant detoxification and cell defense. So you have that healthy cell, it's got the cell danger response going on. If that doesn't shut down, you may wind up with cell death, but if you have NRF2, is what helps revitalize the cell, right? Real simple explanation. Now we're back to this pathway. In a homeostatic state, Keep one this is all inside the cell, this is inside the cytoplasm of the cell. Keep one binds to NRF2, so NRF2 isn't always active. When you have there's low stress on the system, keep one keeps it bound, and then this thing gets ubiquitinated and cleared out. It doesn't have a long half-life in the body. When there's some level of oxidative stress, NRF2 is separated from keep one, NRF2 enters the nucleus, and that's where all that genetic transmission occurs, where we get upregulation of antioxidant systems, cell defense, and detoxification processes. So here's an even a little bit better slide. And under stress, we see NRF2 gets inside the nucleus. It starts transcribing things. One of those big things that it transcribes or stimulates is heme oxygenase. And that is a huge part, when we break down heme, of our natural ways to reduce our pro-inflammatory state and calm down NF-kappa B. So this NRF2 pathway, you don't have to understand all of the chemistry of this baby, but this is a key way to stimulate the natural, innate detoxification and control of redox state inside your cells. So NRF2 actions, these are just some of them. It increases your antioxidants, and not one of them, but all of them, and it helps turn on the recycling systems, right? It increases drug metabolizing proteins. Is that good? Absolutely. It increases the drug efflux pumps. It increases heat shock proteins, increases NADPH regenerative enzymes, increases growth factors and growth factors receptors, antagonizes NF-kappa B. NF-kappa B, everybody know what that is? That's the big driver of the inflammatory process, oxidative stress in the body. You drive up NF-kappa B, this now pushes out all your IL-6, all the other fun stuff. That drives the inflammation, that drives the oxidative stress. So NF-kappa B, or NRF2 actually antagonizes that. You get NRF2 increases heavy metal binding proteins. And somebody was talking today about trying to bind up heavy metals and get them out of the system. Well, guess what? We have a system in place to do that. Let's just do a better job supporting it, right? How about increases ferritin and controls intracellular free iron? You guys understand the importance of free iron? Do you understand the difference between what ferritin really is? Does everybody really understand that? Because I didn't. In functional medicine, I was taught that ferritin should be somewhere between 90 and 100. Is anybody taught that? So ferritin is stored. It's your iron storage closet. Ferritin is a tissue protein. It is not a serum protein. That is important. So ferritin should not be in the serum. Or if it is, it should be in very low levels. Dr. Kell says it should be less than 20. Okay, I was taught 90 to 100 was good because it gives you an idea how much storage of iron, backup of iron, right? If ferritin is in your bloodstream, that means you have cell damage going on. And that ferritin then leaks out of the cell. And as soon as that ferritin hits the bloodstream, what they find is now apoferritin, which means it ain't got no iron on it anymore. So transferrin is when we're looking at serum iron, there's two irons that can be bound to transferrin, right? Ferritin molecule inside your cells can hold somewhere around 4,500 iron molecules. On average, they say it's about 1,100. But when it dumps out, you release all that free iron. Free iron is what? Damaging. Right? You put free iron outside, it's going to rust. You put free iron in the body, it's going to create oxidative stress. Very reactive. Okay? So the good thing about NRF2, when NRF2 is stimulated, it actually increases ferritin production inside your cells, which is great because as you increase ferritin production, you can then hoard the iron. So part of the process, and one of the things that creates chronic stress or cell danger response, in my opinion, has a lot to do with what we do. We talked about the different types of stress, but one of the biggest things from a dietary standpoint is we eat a ton of processed food in this country, right? And all the processed food we eat has a bunch of adulterated oils and fats in them. And when you eat those adulterated fats to the proportion you eat them, make up your cell membranes and your mitochondrial membranes. If you have all those adulterated fats making up your cell membranes and your mitochondrial membranes, you can't transport oxygen across those membranes. If you can't transport oxygen across those membranes, what do you get? You get cell hypoxia. You have cell hypoxia that induces inflammation, oxidative stress. If you have cell hypoxia, can you run your electron transport chain? Can you make ATP? Nope. So now you have chronic oxidative stress, chronic inflammation, and when you shut down that electron transport chain of the mitochondria, the iron that's part of that electron transport chain becomes free iron. Free iron inside the cell then wakes up all your dormant bacteria, virus, organisms. So here's the deal. Do we get rid of the bacteria, the viruses, and all the organisms? What Cal and some others say is that organisms are either alive, functionally dormant, or dead. The only reason that we have... So what happens is, the organisms are alive long enough, as long as there's free iron around, the organisms have a fuel source. As soon as the free iron goes away, the organisms go into a functionally dormant state. You have chronic stress, right? You got the cold sore virus, right? Chronic stress, tissue damage, free iron released, virus wakes up, 4 or 5 days, your body gets that under control, iron's bound up, virus goes away, right? Maybe it was the lysine you took. Or maybe the cellular intelligence knew what to do. So this is really, really important. If you haven't read Dr. Kell's work, I highly recommend you look that up and read his work. It increases PPAR, it increases itself, it increases VDR expression. Is that important? I know I did this for a while, just blasting people with vitamin D, right? That's another thing I can get off of my little high horse, but if you have sustained levels of 125 vitamin D, there's a lot of issues that go on there, right? So you have to assess vitamin D, right? You need RBC magnesium, because you need magnesium for almost every step of the vitamin D process. You need 25 OHD, and you need 125 OHD. And your numbers, you guys want me to talk about this?
Yeah.
Yeah. So your numbers, you want to look at your 125, and you're in a healthy state. Your 125 vitamin D should be, or your 25 OHD should be 1.3 times, right around there, higher than your 125 OHD. 25 is the inactive form, 125 is the active form. If you see if you have the 125 activated, you probably have some type of chronic stress, chronic infection going on. Do you want to support that person with more vitamin D? You really don't. Because if you have long-term 125D upregulation, it's shown to cause bone demineralization. Not good, right? What's every female looking to support, right? You got to take calcium because your vitamin D, your bone density, right? So meanwhile, they've only looked at her 25 OHDs. Nobody's looked at the 125 OHD. But bacteria and organisms have the ability to deactivate VDR. Is that a problem? Vitamin D and binding to VDR is how you stimulate your immune system and so many things that vitamin D. And the bacteria have figured out how to shut this puppy down. Not such a good thing. And NFR2 increases this HBD2, which is a natural antimicrobial in the GI tract. Human defensins B, I think it is, right? And so when this is also stimulated by our good friend bile, right? But NRF2 helps upregulate that. That's your natural antimicrobial effect. So if NRF2 is being suppressed, you lose antimicrobial support in the gut. Okay? Say I'm blasting my patient with antioxidants, glutathione, doing all this good stuff. I can't figure out why they have chronic SIBO. Can't figure that out. Maybe in an effort to try and support one thing, we're creating another problem. Okay?